Hi everyone, and welcome to a new video about DNS over HTTPS and how to gain back the visibility and control over the DNS traffic in your network. If you don't know what is DNS over HTTPS, I recommend you watch my previous video about this topic here. I will put a link in the video description below as well. As we saw last week, Firefox started to default the feature on their web browsers, and I personally won't be surprised if other vendors follow the same action. Sooner or later, this will be a fact that we, the security administrators, will have to face. Traffic on endpoints will look like this. Users will be surfing the internet without using the golden UDP port 53. As you can see here, on Wireshark, we will keep seeing the HTTP and SSL traffic, but for DNS, this is gonna be a dead line as you see. And of course, if clients are not sending clear DNS requests anymore, this is gonna be the same on your gateway. This means no DNS traffic on your firewall. This means no DNS traffic to your DNS servers. And if you wonder how badly is this impacting your security, let me tell you these few concerns as a start. Now, your clients are sending encrypted DNS requests to some external server that you may not trust. Even worse, your end user might be receiving tampered DNS responses. And I will leave this to your imagination when users start browsing phishing websites because they were directed by a malicious DNS server. Another killer thing would be that all your internal resource names are now exposed to external third-party DNS servers. As users start to query your PAC file or intranet or any other internal system, all these queries are now offered on a golden plate to the external DNS servers. Okay, so now we have known the problem, let's discuss our options. First thing, let's make some firefighting action and reconfigure all these endpoints running Firefox to disable the DNS over to HTTPS feature. Depending on your network size and design, this might take a while to deploy. Just make sure that you covered all those computers, including remote users, those that don't fall under the same Active Directory infrastructure, every client. Or you can control this on the web gateway side. On your proxy, block access to all those DNS servers supporting DNS over HTTPS. This might be effective, but you need to think about revisiting this list of DNS servers to check any modification of URLs or any new additions. Also, you need to ensure that all your users are protected by that web gateway, even those not being at the office. Ultimately, the perfect solution would be a web gateway that understands those type of DOH requests and deal with them as normal DNS ones. Something like what Semantic Secure Web Gateway offers. Let me show you how. Symantec Secure Web Gateway has already multiple type of internal engines that understand different type of protocols. We call them proxies. Here, the HTTP proxy will receive the DOH request and will realize its nature. It will understand that there is a DNS request embedded within, so it will pass it to its neighbor, the DNS proxy, which by design understands every single component of that DNS request. So it will send a new DNS query on behalf of the client and will get the standard DNS response, which will be implanted and sent back to the client as a response to the original DOH request. So let me show you this in action. Here in my lab, I have a Symantec proxy ASRI serving this Windows 10 client. I'll be using Firefox to browse the internet and using Chrome to show you the logs and statistics on the proxy ASRI. As you see here on Firefox, it's configured to use DNS over HTTPS with the default Cloudflare provider. So let me access some public websites like sony.com, nasa.gov, and space.com. On the proxy side, what I'm displaying here is a simple web traffic log. We call it access log. This shows the web requests reaching the proxy ASRI. It simply shows some interesting fields like timestamp, client IP, the destination web category, HTTP methods like get, post, connect, and so on. It shows also the destination URL with the HTTP protocol version and TLS version, and some other fields as well. As you may have noticed that ProxySG supports HTTP version 2 and TLS version 1.3 as well. We may demonstrate these in another video if you like, so let me know in the comments below if you are interested. Anyways, as you see here in the ProxySG access logs, all these post HTTP requests are sent to the DOH server of Cloudflare. Every single request of them contains an encrypted DNS query, which I'm not listing here in this access log. But if we switch it to another version of the same access log that I included the DNS fields to be listed, you will see here what was injected in those post connections. If I search it for Sony, you will see the DNS query and the A record with the website public IP address. Note that it was an encrypted HTTPS request. Similar to space.com, as you see here, this is the DNS record displayed in a clear format. Again, for NASA website, the DNS response contains multiple IPs for the website. Let me show you here the DNS statistics page on the ProxySG, which gives you an overall view on DNS. It's clear here that ProxySG is capable of differentiating the normal DNS and DNS over HTTPS traffic. As you see, here are the total number of queries and responses of each type. One final thing to show you here, if you remember this help page provided by Cloudflare, although in fact the client is configured to use DNS over HTTPS, but this is not detected by the service provider. Simply because the ProxySG received the original DOH request and issued a new normal DNS query on the client behalf. So from the service provider point of view, the DOH traffic didn't reach the 4.1 server, and of course it wasn't a DOH request in the first place. Well, that's it for today. I hope you now know the Semantic Secure Web Gateway capabilities in handling the DNS over HTTPS traffic. If you have any question, please let me know in the comments, and see you later in the coming one. Thank you.